Hi, welcome to Unit 5. We're going to be talking about solving quadratic equations today. So we have factored quadratic equations before, and the main reason why we factor quadratics is because we want to see where they cross the x-axis, like this right here. So when we factor things and we solve, which I'll show you in a little bit, we can find out where the quadratic equation touches the x-axis, if it does at all. So for example, on this one, if a quadratic has two solutions, two real solutions, then it will look something like this. It could be flipped the other way too, but it crosses the x-axis twice. If the quadratic has one real solution, then it touches the x-axis once, like it does right there. And if it has no real solution, then it never touches the x-axis. Okay, so before we get started solving quadratic equations, there is something that we did not get to last semester, and that is called the difference of two squares. It's just a special case of factoring equations. And it looks like this. If I have something like, let's say I have x squared minus 25. So the first term is a square and the second term is a square, and we're subtracting them, we can factor it to look like this. It's just the square of the first one and the square of the second one, and then one of them is a plus and one of them is a minus. And I'll show you why that is if we multiply it out. So if I had x times x, that would give me x squared. 5 times x is 5x. X times negative 5 is minus 5x. And then 5 times 5, or 5 times negative 5 is negative 25. So these two terms cancel out, and so then we just have x squared minus 25. So if you have two squares and you're taking the difference of them, it's just the square of the first plus the square of the second times the square of the first minus the square of the second. And we'll see some examples of that in a little bit. I'll give you some more examples. Okay, so in general, the idea that we can use here is if there are two things that they're saying they multiply to get 0, then at least one of those things has to be 0. So if I have like x, y equals 0, either x is going to equal 0 or y is going to equal 0. That has to be the case if their product equals 0. So we use that, and then here are the steps to solving a quadratic equation by factoring. So you can refer back to that when you need to. I'm just going to go ahead and go through the steps with you because I think it'll make more sense as you see them. Okay, so the first couple here are already factored. So we're just going to do kind of select ones that show you something different, and then you can do the rest of them. So for example, this one here, it's already factored for us. But with the 0 product, we know that either this equals 0 or this equals 0. So we're going to set that up. So either x plus 2 equals 0 or x minus 4 equals 0. And then we solve it. So if this one equals 0, then x equals negative 2. And if this one equals 0, then x equals 4. So either one of these is true. Now, when we graph the solution to it, it will show that both of these could be the case. Okay, so here's another one. This one is not factored already for us. We have to factor. So the first thing we always check for when we're factoring is a GCF. So this one has 8 and b can be taken out of both of them. So I'm going to put 8b in front. If I take this divided by 8b, I just get b. And if I take 40b divided by 8b, I get minus 5. So then that means that either 8b equals 0 or b minus 5 equals 0. If this is the case, b equals 0, and if this is the case, then b equals 5. So those are my two solutions. That's what I'm looking for. Okay, let's try a couple more. Let's see. Let's do this one right here, because we have not done factoring since last semester. All right, so if we don't have anything in front here, we're going to do our little factor sums table. And our factor sums table is going to be for 12. So we're looking for the factors of 12, and for our sum, we're trying to get -7. So when I think of 12, I'm thinking of 6 and 2. But if I add those together, I get 8, which is not -7. So I'm going to try 4 and 3, which gives me 7, but not -7. So I'm going to try -4 and -3, because if I do -4 times -3, I get +12, and then that will also give me -7. So this is the one I want to use right here. So I'm going to do my parentheses, and then I have x, and x -4 -3, and that's my answer, or that's the equation factored. So now I set x -4 equals 0 and x -3 equals 0. So in this case, x would equal 4, and in this case, x would equal 3. Okay, go ahead and try it up to this point. So I'm not giving you too much at once. So go ahead and try those 1, 2, 3, 4, 5 problems, and then come back and check your answers for this. Okay, here are the answers for the first 8 problems, so you can go ahead and check those and make sure if there are any of them that you're not understanding that you're writing them down so that we can go over them in class. Okay, let's take a look at a couple other types of problems here. So the first one is a review, sort of. It's a review with a little bit extra. So on this one, we have not only a number here, but we have a number here. So it's got a coefficient other than 1. So you might not remember, but how we do that is we're still going to do a factor sums table. But for our factor, we're looking for our coefficient, our A number times our C number. So we do 2 times -18, and we get -36. So that means we're looking for factors that multiply up to get -36. And then we want our sum to still be +9. So when I think of -36, I'm thinking of 9 and 4, -9 and 4. When I add those together, that gives me -5, which is not 9. So I'm going to try something else. I'm going to try 12 and -3, which when I add those up, do give me 9. Okay, so now it is a little bit different than we did before. What we're going to do is we're going to rewrite the first term, and then this term right here, we're going to rewrite as those two things. So instead of plus 9x, we're going to write plus 12x minus 3x. So it's equivalent, we're just writing it a little bit different to help ourselves out here. And then we are going to factor by grouping. So I'm going to group these two together and factor out a GCF. So my GCF here is 2x. And when I take 2x squared divided by 2x, I get x, plus 12x divided by 2x is 6. And then here I'm going to factor out a -3, and I get x plus 6. And all of that equals 0. So now I have 2x minus 3 times x plus 6 equals 0. And then I have to set both of those equal to 0. So let's see, let me give myself a little more room here. So I can do 2x minus 3 equals 0, add 3 to both sides, and I get 2x equals 3. So x equals 3 halves. And then if I do x plus 6 equals 0, then x equals -6. So this one, I get x equals -6 and 3 halves. All right, let's try one more. Let's see, let's do this one right here. So this one's going to end up being a difference of 2 squares, but first, just like everything, we always have to check and see if we can factor out a GCF. So in this one we can factor out a 2. So when I factor out 2 from that, I get x squared minus, when I take the 188 divided by 2, I get 144, which is a perfect square. And so when I have a factor of 2 squares, I do the square root of the first, the square root of the second, and one is a plus and one is a minus. And then I just set all of that equal to 0. 2 can't be equal to 0, but x plus 12 could be equal to 0. And then that would give me x equals negative 12. X minus 12 could be equal to 0, and that would give me x plus 12. So my answer is x equals plus or minus 12 like that. And you could write it like that, or you could write it like that if you want to. All right, you try those other 4 and come back and take a look at the answers. There are the answers for those. And we're going to do the rest in another video.